Now we're supposed to write the slope-intercept form. Now, as soon as I see that, this is what I'm thinking. Y equals mx plus b, so I need to get m and b. Now, as soon as I see this, when I see this, write the slope-intercept form for an equation. I want to write the equation of a line. As soon as I see that, here's what I think. I think these two things right here. I think these forms right here, y equals mx plus b, and y minus y1 equals m times x minus x1. These are the two templates for equations of lines. Now, of course, I'd like to be able to use this one, this form here, because all I have to do is just substitute m and b. Now, it turns out we have m, all right, so we have m equals 0, but not b. We don't have b because we have this point here. We have 5, 3, and the y-intercept always looks like this. 0 something. It's where the line crosses the y-axis. So you're not to the left of the x-axis, of the y-axis. You're not to the right. So the y-intercept always starts here with a 0. We have 5, 3. So because I don't have m and b, I'm going to use this form. So if I don't have both m and b, go directly to this form. So I'm going to use y minus y1 equals m times x minus x1 with, now here's what I know, y1. Well, I look up here, I only have one y. That's the first y I see. So up here, this is y1. This is the first and only x I see. So what I'm going to do is I'm going to use this form, y minus y1 equals m times x minus x1 with m equal to 0. We're given that. x1 is 5. That's the first x I see, the only x I see. And y1 is 3. The first y I see, the only y I see. So let's substitute. So we'll get y minus 3, right? Just substituting 3 for that y1. And then m is 0. All right, so I'll put a 0 in here. X minus x1 is 5, but it turns out that 0 times anything is 0. So here's what I'm left with. Y minus 3 is 0. Get it in the right form, just solve for y. I'll get y equals 3. And I'm going to claim that that's my equation. And you may remember that if you have just one variable in your equation, it's either, the line is either horizontal or vertical, and if it's y equals 3, it's cutting through the y-axis at 3, so we are going to get a horizontal line. We want to write the slope-intercept form equation for a line with these characteristics. Now, as soon as I see write the equation of a line, I'm thinking this. I've got two templates, y equals mx plus b, and y minus y1 equals m times x minus x1. And of course, I would like to use this form here because all I have to do is substitute m, which I have, and b, which I don't have. B, remember, is the y-intercept, and the y-intercept always has this form right here. The first component is 0, and up here, our first component is not 0, so this is not where the line crosses the y-axis. So as soon as I don't have this, I'm going to go to this. So I'm going to use y minus y1 equals m times x minus x1 with, okay, m equal to, now they give us that. I'm going to write as negative 5 over 7. x1, well, the first x I see, when I look at this point, the first x I see, in fact, the only x I see is negative 2. And y1, as I look, that's the first y I see. It's the only y I see, so that's negative 3. So I'm going to substitute negative 5/7 into m negative 2 into y1, and negative 3 into, negative 2 into x1, and negative 3 into y1. So let's do that. I'll do it up here. So we'll get, if I can get it to right here, we'll get y minus y1. Now be careful with these negatives. Y minus negative 3 is equal to negative, m, negative 5/7 times x minus x1, which is negative 2. Let's get rid of all those negatives. So we'll get y plus 3 equals negative 5/7 x plus 2. And now we'll distribute. So this will give us y plus 3 equals negative 5/7 x. Now, negative 5, can we do this one here? Here's how I see this. I'm going to take negative 5/7 times 2. Now, if I'm dealing with fractions, I'll make everything a fraction. So how about negative 5/7 times 2 over 1? Nothing cancels, so I get negative 10/7. All right, so we'll get y plus 3 equals negative 5/7 x minus 10/7. Now we're almost there. I need to get that 3 off that left side, so I'm going to subtract 3. So we will get y equals negative 5/7 x minus 10/7 minus 3. Now we have to deal with this. So I'm going to get a common denominator here. I'll have y is equal to negative 5/7x minus 10/7. Now minus, what do I have here? It's really what? A 3/1. So how do I get from a 1 to a 7? I multiply it by 7, so multiply the top by 7. So I'll have y is equal to negative 5/7x minus 10/7 minus, put a 7 here, but I multiply the 1 by a 7, so multiply the top by a 7. 3 times 7 is 21. And now just deal with those. So y is equal to negative 5/7 x. Now, negative 10 minus 21 is minus 31/7. Well, look at this. It says, write the slope-intercept form of an equation. And as soon as I see that, I'm thinking these two templates, y equals mx plus b, the slope-intercept form, and y minus y1 equals m times x minus x1, which is called the point slope form. I'll write those so that we can refer to them later if we have to. This is the slope-intercept form. And this bottom one is called the point slope form because you're given a point, x1, y1, and the slope. All right, so these are the two templates that we're always going to use. So as soon as I see write the equation of a line, I'm thinking these two templates. Now, of course, I'd like to use the top one, but what does the top one mean that you have to have? I have to have the slope, which I don't have. I don't have the slope. I mean, I can get it. I have 2 points. And I need the y-intercept. Now, neither one of these points is the y-intercept. This is not on the y-axis, right? It's 2 to the left, 5 up. This is 2 to the right and 3 down. Remember that y-intercept always looks like this. 0, let me write it so I can read it. 0b, right? That first component has to be 0. So I don't have this, so I'm going to go directly to this. So I'm going to say, let's use y minus y1 equals m times x minus x1 with m equal to, now I don't have m, but I have 2 points, so I can get m using the slope formula, which is, get it to right here, y2 minus y1 over x2 minus x1. And I have 2 points. So as I'm up here at the top now, as I look left to right, I see x's and y's. In fact, this is the first x I see. That's the first y I see. This is the second x I see. That's the second y I see. So let's substitute these values in. So we are going to get, you know what, I'll do it down below. It's the second y minus the first y. So the second y is negative 3 minus the first y, which is 5. So this is going to be negative 3 minus the first y, 5, over the second x, which is 2, minus the first x, which is negative. So it's 2 minus negative 2. So we're going to get negative 8 over 2 plus 2. So we'll get negative 8 over 4. So it turns out the slope here is negative 2. Now, let's substitute into our form, our template up here. Here's our template. Y minus y1. I've got a y1, which is 5, and I have an x1, which is negative 2. Now, it doesn't matter, as it turns out, which one you use. We'll have to manipulate a little bit, but at the end, we'll end up with the same equation. So let's substitute. So we will get y minus y1. Now, the first y I see is at 5, equals m, negative 2, times x minus x1, but x1 is negative 2. So this will be y minus 5 is equal to negative 2 times x plus 2. I'm going to distribute. So we'll get y minus 5 is equal to negative 2x. Now negative 2 times positive 2 is minus 4. Let's add that 5. So we'll get y equals negative 2x. Now what do you get here? Negative 4 plus 5 is plus 1. Let's find the slope-intercept form. I want to write the slope-intercept form of an equation. Well, there it is. Write the equation. So as soon as I see that, I'm thinking these two templates, y equals mx plus b, the slope-intercept form, and y minus y1 equals m times x minus x1, the point-slope form. Now, can we use the top one? Do we have the slope? Now I look over here, I don't have the slope directly. So because I don't have it directly, I'm just going to go directly to the bottom one here. So I'm going to use y minus y1 equals m times the quantity x minus x1 with, okay, m equal to, now I don't have the slope, but I have 2 points. So I'm going to use the slope formula for this, which is y2 minus y1 over x2 minus x1. And as I look left to right here, up at the top, as I look left to right, this is the first x I see, that's the first y. This is the second x, that's the second y. So let's substitute into our slope formula down here to get the slope. So we will get that the slope is, okay, second y minus first y. So looking up here, second y minus first y is 4 minus 0. So we'll have a 4 minus 0. And then down at the bottom it says to take the second x, subtract the first x. So the second x minus the first x. So how about negative 11 minus 5? So we will get 4 over negative 16. I can reduce to how about 1 over negative 4, but I'm going to write the negative on the top. So I'll write it as negative 1/4. So there's the slope. Now, let's substitute into our point slope form, right, into the point slope form. So we are going to have y minus y1, and the first y I see, you know, as I look over here, the first y I see is 0. That's nice. Always nice to work with zeros. Equals m, which is negative 1/4 times x minus x1. And the first x I see is a 5. So this is going to be 5. So what do we get? Y minus 0 is y. Distribute. We'll get negative 1/4 x. Now, here, negative times negative is positive. So I'll get positive. Now, here's how I'm going to do this. This is a whole number, 5 over 1. So multiply the tops together, multiply the bottoms together. 1 times 5 is 5. 4 times 1 is 4. And there we go. Write the equation of a horizontal and vertical line that passes through this point. All right, so here's the point that we have. -1 and 1. Now, horizontal lines and vertical lines. Now, a horizontal line looks like this. A horizontal line cuts through the y-axis. Now, it doesn't matter what x is. No matter what x is, y is that number right there. No matter what x is, y is always the same. Now, what's the y here? That's the y. It's 1. So we're going to have, now it's a y, right? It cuts through the y-axis, so you just write y equals 1. Now, vertical lines, okay, vertical lines, those cut through the x-axis. And it doesn't matter what y is, x is always the same. So what is the x for us? Right there. So you just write x equals -1. That's it. Now this says to find a linear function. Now a linear function just looks like this. Y equals mx plus b. But the function name that they're giving us now is h. So instead of y, we're going to write h of x. So what we want to write is this. H of x equals mx plus b. So instead of y, we're just using the function notation. So this is what we want to find. Now, this is finding the equation. All right, as soon as I see equation, write the equation. I'm thinking this. These two templates. Y equals mx plus b, the slope-intercept form, and y minus y1 equals m times x minus x1. Those are the two templates. Now, can I use the top one? That's the easiest one to use. So do I have the slope? I don't have the slope. So as soon as I don't have one of those, I'm going to go directly to the second one. So I'm going to do this. I'm going to use y minus y1 equals m times x minus x1 with, right, m equal to, now we don't have the slope, but I do have 2 points. So look what we're given here. Now we just have to read through this notation. This is really when x is 6, y is -16, right? When the input is x. When x is 6, h, that's y, equals -16. So we really have this point right here. We have the point 6, -16, and then over here it says when x is -1, y is 12. So we have this point, -1 and 12. So now I have this. This is the first x I see. That's the first y I see. This is the second x. This is the second y. So let's substitute those values, substitute these values down into our slope formula. And our slope formula is y2 minus y1 over x2 minus x1. So we will get, okay, second y minus first y. So up here, the second y is 12 minus the first y. So 12 minus -16 over the second x. Now, up here, the second x is -1. First x is 6. So this is going to be -1 minus 6. So we are going to get 12 plus 16 all over -7. So how about the slope is 28 over -7? Oh, nice. This happens to be -4. Now, let's substitute into our form. So I'm going to substitute into this form right here. I've got a y1, I've got m, and I've got x1. Here's the y1, and here's the x1, and we just computed m. So I will say, actually, you know, I'm going to complete this sentence here. I said, use y minus y1 equals m times x minus x1 with m equal to this number and x1 equal to 6, y1 equal to -16. So substitute those values. We will get y minus y1, which is -16, equals m, -4 times x minus x1, which is 6. So how about y plus 16 equals -4 plus 24. Now I'm going to subtract that 16. So I'll get y equals negative 4x, and then 24 minus 16 is 8. But now our function name is h, so I'm going to replace that y with an h, and I'm going to write it like this. H of x is equal to negative 4x plus 8. There's our function. That's the first part of what we want to do. And then we want to find h of 4. All right, so this just says when you replace that x with a 4, replace all the x's with 4. So h of 4, now you can you see it here? H of x, h of 4. That x has been replaced by 4. So just go over here to the instructions and replace all the x's with 4. So it's going to be h of 4 is equal to negative 4 times x, which is 4, plus 8. This is negative 16 plus 8, which is negative 8. So I'll write it up here. H of 4 is negative 8, if I computed everything correctly.